Welcome to integration. Put simply, integration is the opposite of differentiation. We're going to take a differentiated function, so dy over dx equals 4x cubed plus 3x squared plus 1. Sounds simple? It more or less is. To integrate it, as is shown in my earlier video, how to differentiate and integrate in under 3 minutes, you've got to add 1 to the power, divide by the new power. So y equals 4x to the 4 over 4 plus 3x cubed over 3 plus x. Therefore, y equals x to the 4 plus, well, yeah, x cubed plus x plus c. C is monstrously important. Monstrously important. Because C is, well, C in the y equals mx plus c is your y-intercept. Now, the one thing you must remember about an indefinite integral, it does not give you a c value, so one must add c on the end. Now, I think in Core 1, if you forget the c, unless they specifically ask for it, you don't lose any marks. But in every exam onwards, you know, C2, C3, C4, M1, M2, D1, D2, and further pure exams, you will lose marks if you don't put the c on the end of when you integrate. So I would strongly advise you do, otherwise your exam papers may end up looking slightly bad. And one must then work out, well, what's c? So we're going to take a random coordinate. We're going to take 2, 1. Now, that means that the curve, or whatever equation that is, passes through this point. Now, obviously, we know that the 2 is an x value and the 1 is a y value. Therefore, we know that 1 equals, well, 1 equals 2 to the 4 plus 2 cubed plus 2 plus c. Therefore, we know that 1 equals 16 plus 8 plus 2 plus c. So 1 equals 26 plus c. Therefore, we know c is minus 25. So therefore, your entire equation is written as y equals x to the 4 plus x to the 3 plus x minus 25. That is what your finished equation should look like. You have your c term, and as you can see by what we've done previously, what we have done is we have integrated, we've added 1 to the power divided by the new power, and then we made sure that we've put the c term on the end, and to figure out the c term, we've used whatever coordinate we have, in this case 2, 1, substituted the values in to end up with your c term. Now, there is another type of integration called definite integrals. But before then, I'll quickly give you a little bit of background with integration. Integration is incredibly important. Starts in C1 because you need to do the area under curves, but also many other applications, particularly in mechanics 1, 2 and 3, when you're looking at the differences between acceleration, velocity and speed, you will need integration then, and also differentiation for kinematics. Now, we're going to take the other thing, which is definite integrals. Excuse my signs, I know they're awful. I will try and rectify them in future videos. We're going to take x squared plus 2x dx. Now the dx is important because it shows it's a definite integral. Now, just integrating that, as I'm sure you're aware, will give x cubed over 3 plus x squared. Now, usually definite integrals have limits, so in this case we're going to use 2, 1 limits. So we want to find the area of the curve between the point x equals 2 and x equals 1. Now, okay, you're probably thinking this doesn't sound too hard. It's not. So we're going to do 2 cubed over 3 plus, excuse my camera rig, it's acting up, plus 2 squared minus, because it's an area, we need to minus the 1 cubed over 3 plus 1 squared. So if we go further, what we end up with is 8 over 3, draw a bracket around that, plus 4 minus 1/3 plus 1. So that gives you effectively 8 over 3, which is 2 2/3, so that gives you 6 2/3 minus 1 1/3, which gives you the answer of 5 1/3 units. I'm hoping that's incredibly clear. I'm sorry for the paper moving up and down, that's my fault with the rig. I will again rectify this in future videos so it's a bit easier to do. So yeah, you kind of see, hopefully just by looking at that you see the method of what we've done. We substituted the values for the definite integral in, and as a result we've ended up with the answer. We've minused 1 from the other, and you've ended up with 5 1/3 units as your answer. I'll underline that. And with the other one, we have integrated it, and then we've used a coordinate in order to find the c value. Thank you very much for listening. I hope this was useful for you. Goodbye.